We're going to start another brand new topic called sequences. First of all, a sequence is a horizontal list of term values. So you can see here we have 4 term values. However, the sequence would go on forever. And each term value is generated using a particular rule. We're now going to look at a specific type of sequence which is called a linear sequence. The sequence that I've written out here is a linear one because it's either going up or down by the same amount each time. So if you look at each term value, you'll notice that to get to the next term value, we're adding on 2 each time. So to get from 3 to 5, we're adding on 2. To get from 5 to 7, we're adding on 2. And to get from 7 to 9, we're adding on 2. So that's why it's a linear sequence. It's either going up by the same amount each time, or it could be going down by the same amount each time. And the amount that it goes up or down by is called the common difference. So this linear sequence would have a common difference of +2. Okay, another linear sequence, we could have something like that. So in this linear sequence, you can clearly see it's going down by the same amount each time. So we're subtracting 3 from each term to get the next term value. So that's why that's also a linear sequence. It's going down by the same amount each time. And the amount that it's going down by is the common difference. So for the second sequence, the common difference would be -3. Okay, what we're going to look at now is how to get the nth term formula for a linear sequence. Okay, now if we take a look at our example 1 here, it says for each linear sequence below, find the nth term formula and then find the 12th term. So what I'm going to do is I'm going to copy out the term values in this sequence in part A. And just beside those, or level with those term values, I'm going to write down the term value. And there's a little symbol we use to represent all the term values. It is a big capital U with a wee subscript n. So UN just stands for the term values. Now, above the term values, we're going to write down what the term numbers are. Now, this 4 here is the first term. It's the very first term in the sequence. So above 4, I'm going to write 1 because that means 4 is the first term. Above 7, I'm going to write 2 because 7 is the second term. Above 10, I'm going to write 3 because 10 is the third term in our sequence. And above 13, I'm going to write 4 because 13 is the fourth term in our sequence. And level with the top numbers, I'm going to write the term number. And it has a little symbol as well. We call it n. So the first thing you do when you're trying to get the nth term formula for a linear sequence is write all the term values out that you're given, and then beside those write term value UN with a little symbol for term value, Above all your term values, write down the term numbers, and again label that top row the term number n. Now, the nth term formula is a formula that connects each term number n to its corresponding term value un. So what we want to do is get a formula that will connect 1 to 4, that will turn 1 into 4, that will turn 2 into 7, that will turn 3 into 10, and that will turn 4 into 13. Now, in order to get this special formula, the first thing we do is we write down un equals. Okay, that's what our nth term formula starts with, un equals. The next thing we do is we go to the term values and we work out what the common difference is. Now, they're increasing by the 3 each time. So because they're increasing by 3 each time, 3 is the common difference, or plus 3. The common difference will give you the coefficient of n in your nth term formula. So the next thing we write is un equals 3n. And that 3 is the common difference that we just worked out between all the term values. Okay. Now, we need to test to see, is this the correct formula? Will this formula take every term number and turn it into the term value? So, let's start with the first column of numbers. When n is 1, un should be 4. So if we sub n as 1 in here, 3 times 1 is going to give us 3, but un should be 4. So what we have to do is modify this formula in order for 1 to become 4. Now, at the minute when we chuck 1 in, we get 3 times 1 is just 3, but we want it to be 4. So the only way to turn 3 into 4 is if we add on 1. So we're going to have to modify the formula by either adding something onto it or subtracting. Now let's check that it works. And not only that, check that this formula works for every vertical set of numbers. So let's start with the first vertical set. Let's sub in n as 1, and we should expect un to be 4. So sub 1 in for n, so we're going to get 3 times 1 is 3, plus the 1 gives us 4, so it works. Does it work for the next set of vertical numbers? So chuck in n is 2, so 3 2s are 6, plus 1 will give you 7, so it works. What about the third set of vertical numbers? When n is 3, chuck 3 in here, 3 3s are 9, plus 1 will give us 10, so it's working. And then does it work for the last set of vertical numbers? So chuck n equals 4 in here, so replace n with 4, 3 4s are 12, and then add 1, you get 13. So this is the nth term formula for this sequence. In other words, it connects the term number n to the corresponding term value un, okay, which is in the sequence. Okay, so that's how you find the nth term formula for a sequence. Now, the beauty about this formula is it allows you to find any term value, provided you know what the term number is. So for example, I could say to you, look, there's your sequence, 4, 7, 10, 13. What's the 100th term? What you're not going to do is write the sequence out until you get to the 100th term, because that's going to take you quite some time. Instead, to get the 100th term, you just sub in n as 100, and you'll be able to work it out straight away. So that's the beauty about this nth term formula. Okay. So what it then says is also calculate the 12th term in the sequence. So what we want now is the 12th term. So what that means is we're going to sub in n as 12. So go to your nth term formula and replace n with 12. So you're going to get u12, a little 12 low down after the u. And that's equal to 3. And then replace n with 12. We've got to put the 12 in brackets. We're subbing in a number that has a coefficient. And then add on the 1. We're going to do our multiplying here before we do our adding. So 3 12s are going to give us 36. Then add on your 1. And that's going to give you 37. So what we've just found is the 12th term in this linear sequence. The other way you could do it is you could just keep adding 3 until you've got 12 numbers, and then that would be the 12th term. But this method is so much quicker once you know the nth term formula. Okay, let's look at part B. So part B, we have our sequence 8, 4, 0, and minus 4. These are the term values in the sequence, so beside those I'm going to write term value, and we give it a little symbol, u subscript n. These are the term values. In order to get the nth term formula, again, the first thing you do is write the term numbers directly above the term value. So this 8 is the first term, so I put a 1 above it. The 4 is the second term, so I put a 2 above it. The 0 is the third term, I put a 3 above it. And the minus 4 is the fourth term, and I put a 4 above it. And the top row of numbers are the term numbers. So term number, and then its wee symbol is just n. Now, again, the nth term formula will connect each term number n to the corresponding term value un. Now, we start off the formula with un equals. So the formula starts with the term value equals. Now, next thing we do is we work out what the common difference is between all of the term values. So to get from 8 to 4, we're subtracting 4. To get from 4 to 0, we subtract another 4. And then to get from 0 to minus 4, we subtract another 4. So it's a linear sequence. It's going down by the same amount each time. So we've now worked out the common difference, and it's minus 4. The reason we get the common difference is because it tells us what the coefficient of n is going to be in our nth term formula. So the coefficient of n is going to be minus 4. So on the other side of our equal sign we write minus 4n. So at the minute we have some sort of an nth term formula which is hopefully going to connect each term number n to its term value un. So let's test it now with the first set of numbers, 1 and 8, to see does it work. So in other words, when n is 1, we're expecting the term value un to be 8. So if I chuck n as 1 in here, minus 4 times 1 is just minus 4. But we want it to be 8. So you've got to ask yourself, how do you get from minus 4 to 8? Well, you're going to have to add on 12. So that's what I'm going to do. I'm going to add on 12. So I'm modifying the nth term formula. So let's check, does it work for the first two numbers now? So when you sub in n as 1, you want to get an answer of 8. So minus 4 times 1 is minus 4. Add on 12, that's going to give you 8, so it works. Does it work for the next pair of numbers? So chuck in n as 2, minus 4 times 2 is minus 8, and then minus 8 plus 12 is going to give you 4, so it works. And I'll let you into a secret. If it works for the first two pair of numbers, it will work for every pair. Let me just prove it to you. Chuck in n as 3. So minus 4 times 3 is going to give you minus 12. And then add on 12, you're going to get 0. And then chuck in n as 4. Minus 4 times 4 is going to give you minus 16. And then add on 12, it's going to give you minus 4. So it's a brilliant little formula. So we've now got the nth term formula that connects each term number n to its corresponding term value un. Now we're going to use it to work out a particular term value. So again, it wants us now to work out the 12th term. So we're going to sub in n as 12. So go to your nth term formula and replace everywhere you see n with 12. So we're going to have u with a little subscript of 12, that means the 12th term. And then that's equal to minus 4, and then replace n with 12. Put it in brackets because we're subbing a number in that has a coefficient, and then add on 12. We'll have to do our multiplying here first, so minus 4 multiplied by 12 is going to give us minus 48. And then we add on the 12, and then that's just going to give us minus 36. There you go. That will be the 12th term in our list here, of our sequence. So if you kept writing this sequence out and then stopped once you got to the 12th term, you would find that it would be negative 36. Okay, let's look at part C. So part C, we'll write out our sequence here. Remember, these are all the term values in our sequence. So term values are 5, 6, 7, and 8. And then label that row term value. And then that's the symbol for that is big capital U with a wee subscript n. Okay, in order to get the nth term formula, we have to write the term numbers above each term value. So this 5 is the first term, 6 is the second term, 7 is the third term, and 8 is the fourth term. And the top row will be labelled the term number n. Now, to get our nth term formula, we start with un equals. That's the way it starts. The term value equals. So now we've got to get what the formula is. So we start by working out what the common difference is. So go to your term values and identify what you have to do each time to get to the next term value. So 5, to get from 5 to 6 we add on 1. To get from 6 to 7 we add on 1. And to get from 7 to 8 we're going to add on 1. So plus 1 is the common difference. And the common difference, remember, is going to tell us what the coefficient of n is in the nth term formula. So on the other side of the equal sign, we're going to write 1n, or plus 1n. Remember, coefficient of n is the common difference. And now we've got some sort of a formula here. We're going to test to see if it works. So this formula should hopefully connect each term number n to its corresponding term value un. So let's see. If we chuck in n as 1, do we get 5? So replace n with 1. 1 times 1 is just 1, but we want it to be 5. So how do we get from 1 to 5? We have to add on 4. Again, check that it works. If you chuck in n as 1, do you get 5? 1 times 1 is 1, plus 4 is 5. It works. Will it work for the next pair of numbers? Chuck in n as 2. 1 times 2 is going to give you 2. 2 plus 4 gives you 6, so it works, and it will work for every pair of vertical values. So we've now got the nth term formula that connects every term number to its term value. Now we're going to use it to work out a particular term value. So it says work out the 12th term. So again, we want the 12th term, so we sub in n equals 12. So go to your nth term formula and replace everywhere you see n with 12. So we're going to get u12, that's equal to 1, and then replace n with 12, put it in brackets, we're subbing in a number that has a coefficient, and then add on 4. Again, do your multiplying first. 1 times 12 will give us 12, and then add on 4, and that's just going to give us 16. And that will be the 12th term in our sequence. Again, you could check it also by adding 1 on each time and then stop when you've reached the 12th term, and you'll find that it will be 16.